Our lesson for this weekend for our flipped classroom is on describing distributions. Distributions come from the general shape of a histogram of a set of data, which we have already covered in class. It takes into account the numerical data values and their frequencies. Let me show you what I mean. Here we have a histogram covering a set of data, which is heights of students in inches. On the bottom of our histogram, we have our heights, and along the y-axis, we have our frequencies. As we can see, the data values in the center have a higher frequency. This tells us that there are a few students who are shorter and a few students who are taller than the rest, whereas there is an average, which most students have about that height. Since we can see that there is a high point in our graph, that is where our mean will be, our x-bar of a sample. Now, our general shape comes from the height of the bars, so we can go ahead and we can draw a general curve above these bars, just like this. This is our distribution. This is the shape that we are going to be talking about. This general shape is called the bell curve, or a bell-shaped curve of the histogram. This is our symmetric or normal shape distribution. As you can see, this distribution is higher in the center and it slopes off on both sides. These sides are called the tails. It's called symmetric because if I draw a line straight down the center of my bell-shaped curve or my histogram, it's symmetric. I can fold it on top of itself just about. We're looking for an approximation here. It does not have to be exact. The mean, median, and mode tend to all be in the center in the same position for this type of curve. Our next type of distribution is a uniform distribution. Our histogram here shows the amount of actual TV time of a 30-minute show. What we mean by this is that a study was done and it was found that approximately 22 minutes of actual show time were shown when taking out all of the commercials. From this information, we can assume that the mean, our x-bar, of 22 would be in the center of the data. We would also say that it would probably range from about 18 being the low time and 26 being the high time. Although the bars are not all exactly the same height, they are about the same height. So we can just about draw a line across the top. It goes up and down a little bit, but it's generally straight across. This is why we call it a uniform distribution. All of the entries or data values have approximately equal frequencies, which are the heights of our bars. Now, a uniform distribution is always symmetric. We cannot, however, say that a symmetric distribution is always uniform. It does not work both ways. Our third shape of a distribution is a distribution which is skewed right. This distribution can also be said to be positively skewed. The histogram we have this time shows the salaries of McDonald's employees. As we can see, the lower salaries, which are on the left end of our graph, have a much higher frequency than the high salaries, which are on the right side of the graph. This tells us that there are more people who work at McDonald's, which make a lower salary than there are employees who make a high salary at McDonald's. This makes sense because there are more people who are earning minimum wage working at the counters and in the kitchen than there are CEOs of the company and owners who earn the higher salaries. I can go ahead and draw the general shape of this graph. This time we see that the data is not centered. We also seem to have only one tail for this distribution instead of two. The tail tells us which direction the data is skewed. Since the tail is on the right side of our graph, our data is skewed to the right. Or we could say our distribution is skewed to the right. Now let's think about our measures of center, our mean, median, and mode, and where they would be located on this graph. The mode is the value which occurs the most often, so that would go with the highest bar, which has the highest frequency. Our mean is normally centered in our distribution, but since we have a few high salaries, those high salaries pull our mean towards the right of our graph. Our median will normally be in the center of these two values. The fourth shape of our distribution is one that is skewed to the left. This can also be said to be negatively skewed. Looking at our histogram of grades on a test, we can see that the majority of students got a high grade, whereas a few got lower grade. We can go ahead and draw the general shape of this distribution as well. As we can see, the tail is now on the left side of the graph. Remember, the tail tells us in which direction the distribution is skewed. So since our tail is on the left, our distribution is said to be skewed to the left or negatively skewed. When we talk about our measures of center with this distribution, our mode is always the data value that occurs the most often, so that will go with that high red bar. Our mean is normally in the center, but the lower grades on that test are going to pull our mean to the left, and our median will normally be in the center of those two.